Section 5.2. We're going to look at integrals involving ln x. Remember from Calc 1, you had this rule. The integral of x to a power dx was. What's the rule for the antiderivative of x to a power? Add 1 to the power, divide by the new power, plus c. And that rule worked just fine as long as p was not the number -1. What was wrong with p being the number -1? You'd have 0 on the bottom, wouldn't you? That'd be a bad thing. Never have 0 on the bottom. The good news is, now from what we did in section 5.1, we actually have a rule for that. What's the antiderivative of 1 over x? ln x. How come? Because the derivative of ln x is 1 over x. All right, now when we do antiderivatives, traditionally we have absolute values on there. And the reason we traditionally have absolute values is there's no reason why we couldn't talk about the antiderivative from -2 to -1 of 1 over x. But if we don't have the absolute values, we're going to run into issues. Right? What would this symbol mean in terms of what you know about Calc 1 and antiderivatives? What are integrals? They're areas. So all this symbol means is I take the function 1 over x. The function 1 over x looks like this. And it looks like this. And I'm going from -2 to -1. So all I'm really asking you to do is find this area. So that would be ln x. But you see, if we didn't have the absolute values on there, we'd have a big problem. How come we would have a big problem if we didn't have the absolute values on there? I can't take the natural log of a negative number. Remember, we defined natural log to only be good for x is greater than 0. So that's why when we deal with antiderivatives, we slap the absolute values on there. It allows us to deal with areas like this. So this would be ln of 1 minus ln of 2. The absolute value of -1 is -1 is +1. Absolute value of -2 is 2. So our final answer would be minus ln 2. What happened to the ln 1? ln of 1 is 0. That was one of our properties of ln. Questions on that? Now you do have to be a little bit careful though. I couldn't do this. This would be a bad thing. What's wrong with that? What's wrong with the antiderivative from -2 to 2 of 1 over x? Yeah, -2 to 2 crosses 0. It crosses the asymptote. So you can't do that. So if you're going to have bounds on your integral, your bounds have to both be positive or both be negative. You can't have them crossed. You can't cross the asymptote. All right. So what you're going to see problems in this section that use this rule, but require you to use u substitution. For example, you might have the antiderivative of 1 over 3x plus 2 dx. Anytime you have division, almost any time you have division, you almost always end up having to use u substitution. This time I see I have division, so I'm guessing I need u substitution. What should u be? Usually u is going to end up being the bottom. So u is going to be 3x plus 2. du is then 3 dx. So kind of the same trick that we've seen many times. I need to put a 3 in here to get my 3 dx, which means I need to balance it with a 1/3. So this becomes 1/3 antiderivative of 1 over u du. And now we use our new rule. What's the antiderivative of 1 over u? ln absolute value of u. So this is 1/3 ln absolute value of u plus c. Final answer, 1/3 ln absolute value 3x plus 2 plus c. Questions on that? All right, how about antiderivative of, oh, I don't know, what do you want on top this time? Something big? How about 5x minus 6? Is that big enough? Okay. Now I got to think hard, though. So let's see, up on bottom then, I know over here I want a dx. On bottom, I want 5 halves x squared minus 6x plus 8. Once again, I recognize that I have an integration problem, and I recognize that I have a fraction. Almost any time I have an integration problem and I have a fraction, I need to use substitution. U is typically the bottom. U equals 5 halves x squared minus 6x plus 8. Du is then 5x minus 6 dx. And you can see how well I rigged that problem. Why does that rigged so well? Happens to be exactly what I had on top, isn't it? And so I had to make sure I picked my bottom carefully to make it match my top. So this simply becomes the antiderivative of 1 over u du. That's a nice one. So that's ln u plus c. Final answer, ln of absolute value 5 halves x squared minus 6x plus 8 plus c. Questions on that one? Here's one. Antiderivative of x over x squared plus 9. Not much has changed. U is x squared plus 9. Which means du is 2x dx. All right, same kind of thing. I need an x dx. Well, I have an x dx. I need a 2x dx. So I sneak a 2 in there. I balance it out with a 1/2 out there. This becomes 1/2 antiderivative 1 over u du, which is 1/2 ln absolute value of u plus c. And then quite often when you look at this one, if this one were in the back of the book, final answer would be given as 1/2 ln x squared plus 9 plus c. But they would drop the absolute value symbols. Just have regular old parentheses. Right, and this tends to confuse people a lot. Where did the absolute value goes? Well, for this problem, you don't need them. Because if I take a number and square it, what happens? It's going to be 0 or positive. And then when I add 9, it's definitely going to be positive, isn't it? So every now and then when you're doing your homework, if you're looking at the answers in the back of the book, the absolute value symbols will disappear. And that's all that's happening. You're guaranteed that the bottom is always positive. Or you're guaranteed that the thing inside the ln, is always positive. Is it wrong to have the absolute value symbols on there still? No, not at all. But just in case you run into that in your homework. All right, now you're going to see some problems like this. Let's see, steal one out of the book here. The antiderivative of x cubed minus, I'm going to start with x squared. X squared minus 6x minus 20 over x plus 5. Once again, I see that I have a fraction. So my guess is I need u substitution. So u is? Okay, if I don't think that's going to help, but let's try it. U equals x squared minus 6x minus 20. And then du would be 2x minus 6 dx. Can I do anything with a 2x minus 6 to get a 1 over x plus 5? No, I don't think so. I don't think that helps. I think that's the wrong u substitution. Well, my only other choice is u is x plus 5. If u is x plus 5, then du is dx. So what am I going to do with x squared minus 6x minus 20? All right, so there are two different ways to handle this problem. One is we come here and we write x equals u minus 5. Kind of like we did, oh, I erased it already, one of these problems we had on the board today. Pretty much the same idea. All right, so this is going to become the antiderivative of u minus 5 squared minus 6 times u minus 5 minus 20 all over u du. So I was able to get rid of all the x's this time. I suppose that's a good thing. My question now is, did it help? Can I find the antiderivative of that thing? I think what I need to do is simplify on my top. I think you're exactly right. I think I need to FOIL this out. I need to distribute there. Then I need to combine all my like terms and see what I have. All right, so what's u minus 5 squared? U squared minus 10u plus 25 minus 6u plus 30 minus 20 all over u du. Combine my like terms. Antiderivative of, I've got u squared minus 10u minus 6u is minus 16u. 25 plus 30 is 55. 55 minus 20 is 35. So I simplified my top. That looks better, I guess. Now what? We take the u, put it up on the top, and distribute it. Or just divide it through. What's u squared divided by u? U. So this becomes integral u minus, what's 16u over u? 16 plus 35 over u du. And now we can integrate it. Now we're in good shape. What's the antiderivative of u? 1/2 u squared minus antiderivative of 16. 16u plus antiderivative of 35 over u. 35 ln absolute value of u plus c. And then there's only one step left. The last step is plug it in, plug x's back in. So final answer looks like 1/2 times x plus 5 squared minus 16 times x plus 5 plus 35 ln absolute value of x plus 5 plus c. That's a perfectly correct answer. in a perfectly correct technique, but the book tells you to do this problem a different way. So we're going to do this problem again. So we had the antiderivative of, we had x squared remembered what it was. X squared minus 6x minus 20 over x plus 5. In the book's way is actually more useful because this technique will show up again. So what the book tells you to do, the book says anytime you have a fraction and your power on top is bigger than your power on bottom, or if your power on top is equal to your power on bottom, take the polynomials and divide them. So does anybody remember how to do polynomial division from, you probably saw it in pre-calc somewhere? All right, so we take x squared minus 6x minus 20, and we divide by x plus 5. You do long division, just like you did long division with numbers back in, I don't know, 4th grade, 3rd grade, somewhere in there. All right, so my first thing is an x, and I need an x squared. What times x will give me x squared? X. So I put an x here. X times x is x squared. X times 5 is 5x. And then I subtract. What do I get when I subtract? Yeah, very good. This is where people make mistakes. Remember, you're subtracting, so it's minus 6x minus 5x. A lot of people will tell me right there it should be negative 1x, but it's not. It's negative 11x. So watch out for that. That's the single most common mistake people make on long division. Minus 11x, and I bring down the minus 20. Now I need something times x to get negative 11x. Negative 11. So that's negative 11x minus 55. Once again, subtract. Being careful of your signs, you get positive 35. So what that tells me is if I take x squared minus 6x minus 20 and I divide it by x plus 5, I'm going to get x minus 11, and then I'm going to have a remainder of 35. So I write that as 35 over x plus 5. So here's the deal. This integral, x squared minus 6x minus 20 over x plus 5 dx, becomes the integral of x minus 11 plus 35 over x plus 5. Most of that integral is very good. Can you find the antiderivative of x? Yes, it's x squared over 2. Can you find the antiderivative of 11? 11x. Can you find the antiderivative of 35 over x plus 5? Not directly, but now you have to use u substitution. But now notice this u substitution is a lot less complicated. U is going to be x plus 5, and du is going to be 1 dx, so you're just going to end up with 35 over u. What's the antiderivative of 35 over u? 35 ln absolute value of u. All right, so this becomes, I'll write that all down. This becomes 1/2 x squared minus 11x plus, we have to do this piece separately. We have to do a u substitution. U is x plus 5, but du is dx. And we don't have to do that back substitution thing like we had to do it the other way we did it, which means we don't have to FOIL a bunch of stuff out and combine a bunch of like terms. Works out much easier. So this is... Absolutely. Yeah, right, because when you have an integral and you have adding and subtracting, you can split it into this part minus this part plus that part. And this is the only part that needs the u substitution, so you only do it there. You don't do it on the other parts because u substitution is hard. Make it as easy as you can. plus 35 over u du. So final answer becomes 1/2 x squared minus 11x plus 35 ln, and it would be u, but I'm not going to write u. I'm going to plug my x's back in. Absolute value x plus 5 plus c. A very good question would be, did I get the same answer? Well, my 35 ln x plus 5 matches with my 35x plus 5. I like that. What do you think? If I were to FOIL this and distribute and combine all the like terms, do you think I'd get the same thing? Yeah, I think so. Which answer looks better? This one looks better, doesn't it? More simple. I think this technique of doing the long division, I think it's slightly quicker. And when you do it in that technique, the answer comes out generally in a more simplified form. When you go to take a quiz, when you go to take a test, do I care which way you do it? No, I don't care which way you do it. Either way, it gives you a right answer. But I do think this long division technique is a little bit better. Yes?
What are the rules that we have to look out for to make sure we can do the long division? Would there be a number that wouldn't work, or a time that we would?
Well, as long as the power on top is bigger than the power on bottom, or equal, the long division will work. But you do need to be careful of a little something. When I started copying this one out of the book, this was an x cubed. I changed it to an x squared. There was a reason for that, and let me show you. So let's do the same problem again, except we'll make that x cubed. One little trick when you do long division then. Antiderivative of x cubed minus 6x minus 20 over x plus 5 dx. I could do it the same way. I could do it both the same ways. But think about what would happen here. If I let u equal x plus 5, then I'd have to plug u minus 5 in there, and I'd have to take u minus 5 and cube it. How good are you at taking u minus 5 and cubing it? It's time consuming, isn't it? There does happen to be a formula for it. If you know the formula, then you're really quick at it. If you don't know the formula, it takes you some time. So again, I think the long division technique is better. However, there's something you need to remember. When you go to do the long division, you've got to have the x cubed, and then you have to put plus 0x squared. Excellent. You need to fill in any missing terms. This goes from x cubed directly to x. You got to fill in the missing one, the 0x squared. And we'll see why in just a second. Minus 6x minus 20. Divided by x plus 5. All right, what times x will give me x cubed? X squared. So I put x squared there. I have x cubed plus 5x squared. And this is why I had to fill in that 0x squared. I needed to fill in the 0x squared so that when I go to subtract, I have like terms. If I didn't have the 0x squared there, I'd have a negative 6x and a 5x squared. I wouldn't be able to combine them. I subtract, I get negative 5x squared, and I bring down the 6x. Then I need a minus 5x. Minus 5x times x gives me minus 5x squared minus 25x. Once again, subtract, being mindful of your signs. 19x minus 20 plus 19. 19x plus 19 times 5, 95. All right? Subtract. Negative 115. All right, so our integral this time becomes the antiderivative of x squared minus 5x plus 19, and then my remainder is minus 115 over x plus 5. From there, pretty straightforward. Antiderivative of x squared is x cubed over 3 minus 5 halves x squared plus 19x minus, what's going to happen with this 115 over x plus 5? Yes, it's really the exact same thing as I had on the previous page, except I think I had 35 on top instead of 115. But you're going to end up with ln absolute value of x plus 5. Let's see. So for that problem, with that x cubed, I think the long division technique is much, much easier than the back substitution sort of technique that you learned in Calc 1. Yes?
Do you want us to show our work for the substitution if it's just like the 115 over x plus 5? Or if we just know it's the ln x plus 5?
I would hope that very quickly you would start to recognize that if I'm going to have to do a u substitution here, but u is x plus 5, so du is dx. So I don't have to worry about adding any little number in or taking and balancing it. So I'd be fine if you didn't show the u substitution. Be careful, of course, if that's a 2x plus 5, then u would be 2x plus 5, so du would be 2 dx. So you do need to balance out that 2. So I'm okay with you skipping showing the u substitution there. Be careful to balance out your numbers if you need to, though. Other questions?